Alright, so thank you for joining me here once again. This is Composite Functions Part 2. In my previous video, we did some few examples under composite functions, and then we learned the basic things we need to understand before we tackle a question under this topic. So if you haven't watched it, please subscribe to this channel. Go to the page and search Composite Functions Part 1. Go through those questions and get the basic understanding, and let's continue from there. So in our previous video we spoke about f of x, we spoke about g of x as two functions. We learned that in composite functions we put one function into another. So for instance, if we have any function, say f of x, and another function, say g of x, if we are able to put one of them into the other, we form what we call a composite function. But once we take the examples, you get to understand what we mean by composite function. So in the previous video, we learned that before we tackle any question like this under composite function, we need to find out if this is a function. Now this has been mapped to this. We need to change it into an equation before we can tackle it. So we consider the first one, and to be able to do that, we have to change it into function and bring an equal to sign. So the first one will give me f of x equals the equation given to us, 2 minus x out of 3 plus 2x. And then the second one, we have g of x equals x squared minus 2. And then the third one, we have h of x equals 3x. We learned in the previous video that a function in this form, we are asked to find f of x. It means that the first one is called the outer function, the second one is the inner function. So the outer function containing the inner function f of x, the outer function f of x containing the inner function f of x. So this means we are putting the same function into the same function, and we learn that we compose this or rewrite this as the first function containing the second function f of x. So this is how we write it. And now from here we can substitute. So we learn that everything inside the bracket here is an x, and what this means is that some people also say it's called an input. So we can see x, we can also see an input, and what this means is that if everything here is equal to an x, this means in the function f of x here, which is equal to 2 minus x, wherever we see x, we substitute what? F of x, and f of x is the same what function. That is what it means. So now our f of x will be equal to the function f of x is 2 minus x, and our x stands for what? F of x. And what is f of x? The same function. So I'll bring my bracket here and introduce my function 2 minus x out of 3 plus 2x, and then I can close the bracket and then divide it. Then I'll substitute 3, we have 3 plus 2, and into bracket x here stands for this, and this means we have f of x here that we need to substitute, and f of x is the same as 2 minus x all over 3 plus 2x. So we have this. Now the next thing we need to do is to follow basic mathematics to solve this. Most of us at this point can continue. There are those of us that may have issues, so I'll carry on from there. If you think you can just solve the rest of this, you just need to finish it fast. So now this negative we have here will affect the numerator alone. So let me solve it using the basic steps. So we have 2 minus affects only the numerator, minus 2 plus x, all divided by 3 plus 2x. So I'll put this in bracket, then divide this thing. I'll have 3 plus, this will give me 4, this will give me minus 2x, all divided by 3 plus 2x. So I can choose to bring a positive sign here to separate this function away from the 2. Alright, so we know this is over 1, this is over 1, so we can rewrite this by saying f of x equals 2 plus into bracket minus 2 plus x all over 3 plus 2x, and then separate this. Then I bring my division sign here, this division sign here. Then we have 3 plus 4 minus 2x all over 3 plus 2x. So the next step is, we know we find LCM on both sides. The LCM is 3 plus 2x, 3 plus 2x. So now this is out of 1. We all know that. So this into this will give us 3 plus 2x, multiplying the numerator. So we have 2 into bracket 3 plus 2x, plus this will cancel this. This into this is 1. 1 times everything here will give us minus 2 plus x. Then we repeat the same steps here. This into this will give us 3 into bracket 3 plus 2x. Then this into this is 1. So we have plus 4 minus 2x. So now we can expand the numerator and then complete our division. So our fourth of x will give us, this will give us 6 plus 4x minus 2 plus x out of 3 plus 2x divided by 6. This will give us 9. 3 will give us 9 here. So 9 plus 6x plus 4 minus 2x all over 3 plus 2x. So now we can group like terms at the numerator before we divide. Our next step will give us 5x minus 4. So 5x plus 4 out of 3 plus 2x divided by this, and this will give us 4x plus 13. This and this will give us 13 divided by 3 plus 2x. So the rest is simple. We maintain this side and reciprocate this side. So we have 5x plus 4 out of 3 plus 2x multiplied by 3 plus 2x out of 4x plus 13. So this can take care of this. Now we have our fourth x equals 5x plus 4 out of 4x plus 13. So this is our final answer.